Welcome to Chapter 11. This is a chapter about figuring flow rates, dosage rates for IV medications. So what we're going to learn is we're going to talk about the way IVs are administered. We're going to convert dosage rates, which is drug over time, to IV rates, which is volume over time. We're going to convert from IV rates, which is volume over time, to dosage rates. So we're just going backwards there. We're going to calculate infusion rates when medication must be added to an IV piggyback bag. We are going to calculate infusion rates based on the size or weight of a person, the body surface area. We're going to calculate flow rates for IV push medications. We're going to calculate the duration of IV piggyback infusions. We're going to calculate the flow rates for medication requiring titrations, and we're going to construct a titration table. Now, this sounds awful, but it's really not bad at all. It's more or less the same kind of math we've been doing the whole time. Okay, so this is an example of a setup for IV piggyback infusion. Notice that the secondary infusion is higher than the primary. And this is because we want this to go in first. So being higher, the pressure will be greater than the pressure here, and so this one will enter first. Here are some examples of the type of medication you might have in a piggyback. Okay, notice right here. This tells you it's dropping at 60 drops per milliliter, and right here on this one, it says 10 drops per milliliter. Okay. So, first problem, converting flow rate to dosage rate. Now, what I mentioned it earlier, flow rate is volume over time, and dosage rate is a drug over time. Okay, so let's look at this. An IV is infusing at 100 milliliters per hour. The strength of the solution is 200 milligrams and 500 milliliters. Find the dosage rate in milligrams per hour. Okay, so what do? This right here, 100 milliliters per hour. This is it is volume over time, so this is the flow rate. And we want it to get into milligrams per hour. This is the amount of drug over the amount of time. So what we do is we take the 100 milliliters per hour and we create the 100 over milliliters per hour, and that's 1 hour there. And then we're going to multiply it by the other bit of information we have. We have 200 milligrams and 500 milliliters. Now we're wanting to cancel out milliliters, so we make sure that we put it in the right order so that the milliliters cancel out. So you have the 200 milligrams over the 500 milliliters. Milliliters and milliliters cancel out here. And we have milligrams over hours, which is what we're looking for. And if you do the math, if you multiply straight across and then divide by 500, or if you do cross cancellation like they did here, then you get 40 milligrams per hour. If you look at this, basically if you cancel out these two, and then 5 goes into 120 times, so you have 20 times 2, which gives you the 40. Okay,